Hi Carlos, I've been exploring data structures recently. They seem pretty crucial, don't they?
Totally, Daniel. Data structures are indeed essential. They help us organize, manage, and store data efficiently. Without them, handling complex data would be much more difficult.
I agree, and from what I understand, mastering data structure is important for us developers because they let us manage data effectively. This leads to better algorithm design and improved performance in our software.
Exactly. For example, using the right data structure helps us process large data sets faster and use resources more effectively. It's crucial for building high-performing applications.
That's a good point. Speaking of which, in what type of problems is managing data structures particularly important?
One example is optimizing search and retrieval, like when finding the shortest route on a map app. Another is managing large datasets, such as speeding up data loading times in a system. And for interactive systems like organizing a guest list for a party, choosing the right structure helps keep teams well organized.
Those examples are spot on. For instance, I've seen how financial apps use efficient data structures to handle stock price and perform real-time analysis, and organize a party guest list with structures like arrays or linked lists can help manage the data more effectively.
Great example, Sam. It really shows how data structures are applied in various scenarios.
Absolutely. Have you noticed how some data structures are better suited for different programming languages?
Yes, definitely. For instance, Python dictionaries are great for key-value pairs, while C++ vectors are excellent for dynamic arrays. It's all about understanding the strength for each structure in a given language.
That's interesting. I've also been thinking about how data structure related to databases. They seem to share some similarities.
You're right, databases rely heavily on data structures like trees and hashes to manage and retrieve data efficiently. This is why understanding data structure is so important when working with databases.
I see what you mean. It makes me realize how fundamental these concepts are to so many areas in computer science.
Exactly, Daniel. Whether it's software development, databases, or algorithms, data structures are everywhere. That's why they're a key focus in our engineering studies.
Now, that you mention it, I've also seen how they are used in operating systems. Like, isn't a file system basically a big tree structure?
It is. File systems often use tree structures to organize directories and files, making it easier to navigate and manage data. That's another reason why data structures are so versatile.
Absolutely. Now, what's the difference between data and information?
Good question. Data are raw and process values like coordinates for a location. Information, in another hand, is what you get when process and organize data mentally, such as using those coordinates to create a map that shows location and routes.
That makes it clear. And how do we know if a data structure is efficient?
A data structure is considered efficient if it allows quick operation, like searching, inserting, and deleting data, while using minimal time and memory. Efficiency is crucial, especially when handling large amount of data.
Exactly. So, what's the most valuable insight we can gain from this for our engineering studies at UFPS?
The key takeaway is learning to select the right data structure for each problem. This choice impacts how well our code performs and how efficiently our application run in real-world situations.
I couldn't agree more. Understanding this helps us develop better software and solve problems more effectively.
Absolutely, Daniel. It's all about applying knowledge practically.